Hello there, welcome to the June 2018 applied paper. Here we're looking at question 4. So Charlie is studying the time it takes members of his company to travel to the office. He stands at the door office between 8:40 and 8:50 one morning and asks workers, as they arrive, how long their journey was. State the sampling method Charlie used. Well, let's have a look at what the mark scheme's got. It's got convenience sampling or opportunity sampling. Charlie's taken the opportunity between 8:40 to 8:50 at his convenience to sample all the people who come through the door at that time. Moving on to part B. So either of these two answers would be fine. You just have to put one of them. Part B is state and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. Well, this would be an example of quota sampling where we survey up to the quota of 40, and we might want to, for example, take 4 people every 10 minutes. We may have people arrive in bunches where there's a bus ride that's just come in, and it would be not very sensible to take all of those people because they would all be similar. So if you take it 4 people every 10 minutes, you'll get a more spaced out answer and potentially a more accurate answer to your question. So Taruni decided to ask every member of the company the time X minutes it takes them to travel to the office. State the data collection process Taruni used. So if he's asking, or if she's asking every member of the company, then she's taken a census, or he's taken a census. So when you find data for everyone in your population, that is what's called a census. Moving on to parts D, E and F. Taruni's results are summarised by the box plot and summary statistics below. So this is the box plot and these are the summary statistics here. Okay, so write down the interquartile range for this result. So it looks like the boxes are going up in 2s here, so that's going from 28, so it's going to be 28 and then up to 50. So no, not 28, 26 up to 58. So the interquartile range here is going to be 32 minutes. Moving on to part E, calculate the mean and the standard deviation for this data. Well, the mean is just going to be the sum of x over n. That's adding up all your data, dividing it by how many pieces of data you've got. 4133 divided by 95. And if we do that on the calculator, we're going to get 43.5 minutes. And the standard deviation is the square root of the sum of x squared over n minus 43.5 squared. And if we do all of that, then that's going to give us, let's just do that on the calculator, 15.4 minutes. 15.4 minutes. Good, okay, moving on to part F now. State, giving a reason, whether you would recommend using the mean and standard deviation or the median and interquartile range to describe this data. Well, because there are outliers, the mean is affected by outliers and the standard deviation is affected by outliers. So where there are outliers, it might be better to use the median and the interquartile range. So they use the median and interquartile range due to the outliers. Okay, so there's our answer then. Use the mean and the median and the interquartile range due to the mean and the standard deviation being affected by the outliers. Let's move on to the next part then. So Rana and David both work for the company and have both moved house since Taruni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes, and David's journey to work has changed from 60 minutes to 33 minutes. Taruni drew her box plot again and only had to change 2 values. This was the original box plot. This isn't the changed box plot. This is the original. So explain which two values Taruni must have changed and whether each of these values increased or decreased. So what we've got here is we've got one data value going from 75 to 35. So that's going to go in here, and we've got another data value going from 60 to 33. So 33 would come in about here. So what's going to happen there is the median line will definitely have to decrease. So the median will decrease because we now have more data inside this region here. And remember, each region should only occupy 25% of the data. So the median line will decrease. Median will decrease. And also the upper quartile will decrease because now the median will decrease to probably here, and then we'll have two more values in here, so therefore we'll cut off two values here. So because we've added two more data values at this point here, we can then cut off two more data values here, and now that will be included in the bit from the upper quartile range to the maximum point. So it's both the median will decrease and the upper quartile will decrease as well. Quite a nice little problem solving puzzle that. Certainly took me a little while to have a think about what will happen there, but yeah, so it will be the median decreasing and the upper quartile decreasing because we have two people shifting from the effectively the fourth quarter to the second quarter, so therefore the marker for the second quarter will have to move down, as will the third quarter, because we'll now have two people transferring from the third quarter to the fourth quarter, so therefore the marker will have to be moved down a little bit. So there we are. So that's the answer to this question here, worth 13 marks in total for question 4. Let's now move on to question 5.